हेलो माय डियर मैकेनिकल स्टूडेंट्स, हाउ आर यू ऑल? व्हाट्स अप? कैसे हैं सब लोग? प्लीज गाइस डू जॉइन मी फास्ट सो दैट वी कैन स्टार्ट आवर सेशन ऑन टाइम. This is Chandrashekhar welcoming you all to the India's largest, the best and your favorite live learning platform, that is BYJU'S Exam Prep. So those who are watching me live, please respond through the comment section. Please mark your presence by writing in the comment box. Hi Madhu. Good evening. Welcome to the session. How are you? I hope everyone is safe and sound. So first of all, please guys do let me know if my audio and visual quality are fine or not. Are you guys able to hear me properly so that we can start the session? As you can see, today we will be talking about the analysis of radiation exchange between two or more surfaces. In the previous session, we have talked about the shape factor algebra. I hope you are quite comfortable with the concept of shape factor, and I had given you one assignment question also. So if anybody is having anything to ask in shape factor, I will be very happy to assist you. Otherwise, we will talk about the analysis of radiation exchange between two or more surfaces. Before I start the session, let me quickly introduce myself for those who are attending my session for the first time. My name is Chandrashekhar, Mechanical Engineering graduate from IIT Delhi and also an Engineering Services Examination qualified. The rule here is those who are live, those who are watching me live, please keep on writing in the comment section whatever you feel like. If you have anything to ask, just mention in the comment section. If you want to share your knowledge, please do that, please. But it is my humble request to everyone to keep on talking to me through the comment box, right? Then only the class will become lively and you will be having the fun learning the concept of heat transfer. So these are my subjects which I am quite comfortable with, and I am having more than 10 years of teaching experience in GATE, IES and PSUs. There is a contact email ID mentioned over the screen. You can always contact me through the mail ID, and it will be good if you become part of my Telegram group. If you have not joined me yet, you can join me by using the link there on the screen, or you can search me by my name, Mechanical by Chandrashekhar, on the Telegram, and you can be part of my Telegram group, right? And other than the free sessions which we bring on YouTube platform, BYJU'S is also providing you the paid courses which will be helping you to crack the GATE 2023 examination. You can join our paid courses as well. And in the last, before I start my session, I would request everyone to like the session so it reaches to maximum number of audience, and do not forget to subscribe our BYJU'S YouTube channel. Then you will be getting all the updates and notifications of our free sessions which we take from time to time. So first of all, what we are going to discuss in today's session that you should know beforehand so that you can make up your mind. First of all, we will talk about the radiation exchange between the black bodies. What is a black body? Anybody is having any idea about a black body? How do we define black body? What is exactly a black body in terms of radiation analysis? Then we will be moving to the space resistance. Then we will be talking about the space resistance for radiation, and we will analyze the radiation by using the circuit diagram. By using the resistance circuit diagram, we will analyze the radiation. And then we will be talking about the radiation analysis for the non-black body. Yes, Madhu, very nice. The black body is a perfect emitter as well as perfect absorber of any type of thermal radiation. Epsilon is equal to alpha is equal to 1. That is how the black body. No, Deepak, emissivity is equal to absorptivity for all type of surfaces. That is the Kirchhoff's law. That does not make the body to be black body. Very, very important point. Deepak committed the mistake. I want everyone to understand this. Epsilon is equal to alpha. They are equal for all surfaces, whether it is black or non-black. Black or non-black. That is valid for all type of surface. That is called as Kirchhoff's law of radiation. The only condition for applying the Kirchhoff's law is the body should be in thermal equilibrium with its environment. But the value is equal to 1 only when the body is a black body. Is this clear? And then we will be talking about the analysis of non-black body radiation, and then during which we will define another resistance that is called as surface resistance. These will be our agenda for discussion for today's session. All right, shall we start? Are you all ready with your pen, calculator and paper notebook handy? I keep on giving you the questions, quizzes through my Telegram group. Please do try those questions. Without practicing the numericals, you cannot achieve your desired objective. The numerical practice is must to develop the thinking ability, to develop the application approach. So whenever I give you some questions, please make it a habit, make it a responsibility to solve those questions and give me the answer through the Telegram group only. Yes. So I hope everyone is ready to explore the beauty. But first of all, we will discuss the assignment question which was given yesterday. Can you just let me know the answer to the question? Can you just let me know the answer to the question? Deepak, what is the meaning of learning formula? There are two things. Either you are talking about memorizing the formula, or you are talking about understanding how we are developing the formula. That is very, very important. Even if the GATE paper is objective, so do not just memorize the formula without knowing the background of that particular formula. Otherwise, it will not be helping you. Madhu, definitely I will bring conduction and convection also, but because we are having 6 classes, 6 to 7 sessions, so we cannot complete the heat transfer in 6 or 7 classes. We can only complete one particular topic, that too in detail. So the objective of this series is to complete one topic from the heat transfer subject, and that we will discuss in detail. So that is why I have chosen the radiation, because nowadays the radiation is going to be very, very important. Nowadays the questions are frequently asked from the radiation mode of heat transfer. The answer to the question is 0.6, definitely 0.6. Look, the shape factor from between L to M is equal to 0.8 and the shape factor between N to R is 0.4. Now, can we say Q from the energy conservation equation? Can we write this way? Q L to M is equal to, this is, let us say 1, this is 2, this is 3. The surface M can be divided into 3 parts. So can we write it as, from the energy conservation, can we write it as Q LM1 plus Q LM2 plus Q LM3, right? So whatever the radiation leaving from L and reaching M will be summation of radiation leaving M reaching M1 plus M2 plus M3, isn't it? And from, so QLM can be written as A1 into FLM is equal to AL, it is not A1, it is AL into FLM1 plus AL FLM2 plus AL FLM3, isn't it? So area will get cancelled out from everywhere. So FL to M can be written as sum of FLM1 plus FLM2 plus FLM3. That is called a superposition principle. And again, from the symmetry principle, so FLM, can we say these two are equal from the symmetry principle? They are equal. So we can write it as twice of F LM3 plus FLM2. From the symmetry principle, we can say Q1 to 3. I should not write 1 to 3. We can write Q L M1 is equal to Q L M3, isn't it? So from the symmetry principle, we can say F L M1 is equal to F L M3. So this is the expression, and this is 0.8 is equal to this this FLM2 can be equated with NR. So FLM2 will be equal to FNR, isn't it? They are having same areas, having same orientation. So FNR is equal to FLM2, that is given as 0.4. So we can say it is twice of FLM3 plus 0.4. Then we can find out FL2M3 as 0.48 minus 0.4 divided by 2, that is 0.2. Getting it? FLM3. And from the symmetry principle, FLM3, this is M3, is equal to FQ2. This is, let us say, 1, this is 2. So FLM3 is equal to PQ2. Isn't it? And from the superposition principle, FPQ can be written as FPQ1 plus FPQ2, and that is equal to 0.2, and FPQ1 will be same as FNR, that is same as FLM2, isn't it? From the symmetry principle, these will have the same shape factors. So that is equal to FNR plus FPQ2, that is 0.2. So it is 0.4 plus 0.2. So FP2Q will have the value 0.6 as the correct answer. Those who were not able to solve it, I hope they have understood the concept now. If anybody is having any doubt, please do let me know. If anybody is having, we have applied the superposition principle, that is from the energy conservation. We have applied the concept of symmetry principle. When the surfaces are having the same areas and symmetrical with respect to one another, then they will be having the same amount of shape factor. Shape factor is a geometric quantity. It depends on the shape, size, orientation and geometries of surfaces 1 and 2. Is this clear to everyone? So without solving that much, you could have directly solved it. Look, the value of FL to M is given as 0.8 and N to R is given as 0.4. So out of this, L to M2 will be equal to 0.4 and this will be remaining 0.4. And from the symmetry principle, this shape factor will be same as this shape factor. So it will be divided equally. So M1 will have 0.2, M3 will have 0.2 and LM2 will have 0.4 shape factor. Adding these together, we will get the total shape factor from L to M as 0.2 plus 0.4 plus 0.2. And now again, if we talk about PQ, this shape factor is 0.4 equal to NR and this shape factor will be 0.2. So 0.4 plus 0.2 will give you the shape factor from P to Q as 0.6 because the dimensions are also same, 1 meter each. Is this clear? Please make some noise. If the things are clear to you, please write Y in the comment section. Y for yes, N for no. So that I will come to know whether I need to explain again or not, or we can proceed further. Now, the radiation exchange between the black bodies. First, we will talk about the radiation exchange between the black bodies. If there are two or more surfaces in contact, shape factor comes into picture, or we can have the exchange of radiation between the surfaces. All right. Now, if I ask you what is the radiation leaving from surface 1, who will tell me the amount of radiation leaving the surface 1? What is the amount of radiation leaving the surface 1? That is Q1. What is the value of Q1? Yes, everyone. इतने लोग अटेंड कर रहे हैं क्लास को, स्टिल very few people talk to me through the comment section. Keep on. The more you commit mistake, the more comfortable you will become. What is the amount of radiation leaving the surface 1? Q1. How to write Q1? Waiting for your response. We are talking about the black bodies. Black body 1 and 2 both are black body. The area of body 1 is A1, area of body 2 is A2. The temperature of body 1 is T1, the temperature of body 2 is T2. Epsilon 1 is equal to epsilon 2 is equal to 1 because both are black bodies. Emissivities are equal. Q1 is equal to radiosity into A1, isn't it? The amount of radiation leaving the surface 1 will be J1 into A1. That is what? And how much is the radiation reaching the surface 2? Out of this radiation, amount of radiation reaching the surface 2, that is Q1 to 2. How to find out the amount of radiation leaving 1 and reaching 2? Can we write F1 to 2 into J1 into A1, isn't it? Because F1 to 2 is equal to Q1 to 2 upon Q1. That is the definition of shape factor, isn't it? Similarly, in the similar manner, we can say similarly Q2 to 1, the amount of radiation leaving the surface 2 and reaching 1 will be equal to F2 to 1 into J2 into A2. Do you agree or not? So Q1 to 2 is F1 to 2 J1 A1 and Q2 to 1 is F2 1 into J2 into A2. Now if we talk about the net radiation transfer, net radiation heat transfer. What is the net radiation heat transfer? That is Q1 to 2 net can be written as Q1 to 2 minus Q2 to 1, isn't it? Q1 to 2 minus Q2 to 1. And what is that? If you see here, from the reciprocity theorem, do you agree A1 multiplied by F1 to 2 is same as A2 multiplied by F2 to 1, isn't it? From the reciprocity theorem. So can we write it as simply A1 F1 to 2 into J1 minus J2? Do you agree or not? Is this clear to everyone up to this point? This is the net radiation heat transfer from 1 to 2. I hope it is clear. Now, what is J? J is the radiosity. Now, how to calculate the radiosity for a black body? For a black body, as we know, J is equal to E plus rho G, isn't it? Or we can say that is epsilon EB plus rho into G. And for a black body, epsilon is equal to 1, isn't it? And what is the value of rho? For a black body, what is the value of reflectivity of the surface? What is the value of rho for a black body? Epsilon is equal to 1 and rho is equal to 0. Because the black bodies do not reflect anything, that is why they appear black in color. Reflectivity will be 0. If we put this value in this expression, then we can say J is equal to EB. For a black body, the radiosity is equal to emissive power of the black body. Radiosity will be equal to emissive power of the black body. So our previous equation, if I call this equation to be 1, can we write this equation? So equation 1 can be written as, can we write equation number 1 as Q1 to 2 net is equal to A1 F1 to 2 into EB1 minus EB2. Can we write this way? And where, what is EB1? From the Steffen-Boltzmann law, EB1, hi inspired, why you are so late? EB1 is equal to sigma into T1 to the power 4 and EB2 will be equal to sigma into T to the power 4. The unit is watt per meter square. That is Steffen-Boltzmann law. Emissive power of the black body is given by sigma into T1 to the power 4, and emissive power of the black body 2 will be given by sigma into T2 to the power 4, where sigma is the Stefan Boltzmann law. Sigma can be called as Stefan Boltzmann constant. The value is constant, that is 5.67 into 10 to the power minus 8. Is this clear? Is this clear up to this point? Now, we can write Q122 net as, we can write it as EB1 minus EB2 divided by, can I write it as 1 upon A1 F122? Can we do that? Yes, definitely we can do that. Because A1 F122 is multiplied here on the numerator, so we can write it as denominator with a reciprocal. Or we can write it as delta EB upon, this is called as space resistance between 1 and 2. That is called as space resistance. So if we draw the circuit diagram, we are trying to write it, this expression, in terms of the current is equal to potential difference upon the resistance. That is Ohm's law. So we can say, if we draw the circuit diagram or the electrical analogy, we can say the current in electrical circuit is similar to the heat transfer rate in the radiation. I is similar to Q, and delta V, electrical potential, is similar to radiation thermal potential, that is delta EB, and the electrical resistance is equal to thermal resistance. That is called as space resistance. So if we draw the circuit diagram, simple circuit diagram, this point represents EB1, this point represents EB2, and there is a heat transfer Q1 to 2 net between 1 and 2, and the distance is called as delta EB. And the space resistance between 1 and 2 is either 1 upon A1 F122, or we can write it as 1 upon A2 F221. That is called as space resistance between 1 and 2, or we can also write it as, that is the space resistance. What is the unit of space resistance? Between 1 and 2. What is the unit of space resistance? We can write it as R122. So if we want to find out Q122 net, we will write the potential difference or radiation thermal potential divided by space resistance. What is the unit of space resistance? What is the unit of space resistance? The unit of space resistance. The shape factor is a unitless quantity and area is having a unit of meter square. So m to the power minus 2. That is how the space resistance. So when there is a radiation exchange taking place between two black surfaces, we can analyze the situation by using the circuit diagram, where there will be one space resistance coming into picture for the space between 1 and 2. Is this clear? So finally, we can write Q122 net. It is the net radiation heat transfer from 1 to 2 is equal to A1 F122 into sigma into T1 to the power 4 minus T2 to the power 4, or we can write it as minus of Q221 net, isn't it? Because if we want to find out if there is a radiation heat transfer taking place from 2 to 1, then it will be J2 minus J1 or EB2 minus EB1, that is equal to minus of Q221. I hope this is clear. This is very, very important. Is it fine with everyone? Any doubt? If anybody is facing any doubt, please do let me know. Now, if we talk about enclosure, two black surfaces enclosure. If we talk about an enclosure, there is an enclosure having two black surfaces. Let us say this one is black surface 1, and another surface makes an enclosure. This is surface 2. So can we write Q1 net as Q121 plus Q122 from the energy conservation? Can we write Q1 net is equal to Q121 plus Q122, and Q121 will be equal to 0 because temperature is constant. As we know, Q122 is equal to A1 F122 into sigma into T1 to the power 4 minus T2 to the power 4. So Q121 will be equal to 0. Similarly, Q2 net can be written as Q2 net is equal to written as Q221 plus Q222 for an enclosure. Here Q222 will be equal to 0. So can we finally write Q1 net is equal to Q122 net is equal to A1 F122 into sigma into T1 to the power 4 minus T2 to the power 4 is equal to minus Q221 net, or we can say it is minus Q2 net. This is how the concept is applied. This is how the concept can be applied for an enclosure. That is the total heat transfer from the surface, or the net heat transfer or net radiation heat transfer from the surface from surface 1. Yes. Any doubt? Anybody is having anything to ask? Please do let me know. And similarly, for n black surface enclosure, we can say Q1 is equal to Q1 net is equal to Q11 plus Q12 plus Q13 up to Q1n. Similarly, Q2 net can also be written as Q221 plus Q22 plus on Q22n. And similarly, Qi net can be written as summation of j is equal to 1 to n Qij, and that will be equal to AiFij sigma into Ti to the power 4 minus Tj to the power 4. That is net heat transfer. Clear? Yes, Q121 will be 0 because for between any two surfaces, as we can write the general expression between I and J for the black surfaces I and J, we can write it as AI Fi to J into sigma into Ti to the power 4 minus Tj to the power 4. If I is equal to J, then we can say Ti will be equal to Tj, and then we can say Qij will become 0. Isn't it? Yes, Q121 will be 0. Because of temperature 0, because of the same temperature. F121 may not be 0. Are you getting it? RPS inspired. F121 may not be 0. F121 may be 0 or may not be 0. There is a possibility. If the surface is flat or convex, then only the self shape factor be 0. If the surfaces are concave, so the self shape factor will not be 0. That does not mean the heat exchange will not be 0. The heat exchange from 1 to 1 will be 0 because of the same temperature. Now, the next part of the analysis is a little more complicated. Black body radiation analysis is quite simple. There is only one resistance, that is called as the space resistance between 1 and 2. So we can say for the radiation exchange between the black bodies, we can say that is given by delta Eb upon space resistance, and delta Eb can be written by using the Stefan-Boltzmann law. Now, if we talk about the radiation heat exchange between non-black bodies, so epsilon will not be 1 or rho will not be 0. They are non-black bodies. So if I ask you what is the amount of radiation leaving the surface 1 and reaching 2, radiation leaving the surface 1 and reaching 2, so we can say Q1 to 2 is equal to F1 to 2 into J1A1, F1 to 2 into J1A1, and similarly radiation leaving the surface 2 and reaching 1 is equal to F2 to 1 into J2 into A2. The unit is what? The unit is what? So Q1 to 2 net can be written as A1 F1 to 2 into J1 minus J2, or we can write it as delta J upon phase resistance between 1 and 2. That is what we can write. Delta J upon space resistance. So if we draw the circuit diagram for this situation, if they are known black body, then this node represents J1 and this node will represent J2, and between them there is a space resistance. This can be written as delta J. So we can write Q1 to 2 net as Q1 to 2 net can be calculated by J1 by J2, J1 minus J2 upon this is either we write A1 F1 to 2 or we can write 1 upon A2 F2 to 1. That is the space resistance between 1 and 2. Now, how to calculate J? Now, that is a difficult task for a non-black body. If we talk about J, for a non-black body, the net heat transfer from a non-black body, this is the non-black surface. So can we say Q by A net is equal to the radiosity minus insolation J minus G? Q by A net, the unit is watt per meter square, isn't it? J is the radiosity, G is the insolation, and this is the radiosity, right? Or we can write it as J minus G. What we can write G? As we also know, J is equal to E plus rho G. From here, G can be written as J minus E by rho, isn't it? This G can be written as J minus E by rho, or we can write it as rho into J minus J plus E by rho, or E can be written as epsilon EB. That can be written as epsilon EB minus 1 minus rho into J upon rho. Can we write rho as, for a non-black body, as we know that alpha plus rho plus tau is equal to 1 for all the surfaces emitting any type of radiation, and tau is equal to 0 because the surfaces are opaque to thermal radiation. So rho is equal to 1 minus alpha, and according to Kirchhoff's law of radiation, it can be written as 1 minus epsilon, isn't it? Rho is equal to 1 minus epsilon. So 1 minus rho is equal to epsilon. So that can be written as epsilon EB minus epsilon J upon rho can be written as 1 minus epsilon. Is this clear? So Q by A net can be written as EB minus J upon 1 minus epsilon upon epsilon. And Q net, the net radiation heat transfer from the surface, can be written as, so we can say Q net is nothing but it is EB minus J upon 1 minus epsilon upon epsilon A. The unit is watt, and this is called as the surface resistance. This is called as the surface resistance for the non-black surface. So for a black surface, the surface resistance will not be there. So this is called as surface resistance. The unit is again meter to the power minus 2. So what is the physical significance? The physical significance is, if there is a black body, the potential of the black body is EB. The potential of the black body surface is EB. But if it is a non-black surface, then the potential will be J. That is the radiosity. So what we can assume is the non-black body can be assumed to be a black body with a covering. The non-black body can be treated as a black body with a cover. So whenever there is a cover provided to the black body to make it a non-black, there is a surface resistance coming into picture, because we are providing an extra cover to make it non-black, and that will provide some thermal resistance to the radiation heat transfer, and that resistance is called as surface resistance. Getting my point? So if we draw the circuit diagram, then we can say the non-black body can be treated as a black body whose potential is EB, and there is a cover, the potential is J, and there is a surface resistance that is given by 1 minus epsilon upon epsilon into A. So any non-black body can be considered as a black body with a cover, and that will provide one extra resistance, thermal resistance, that is called as surface resistance. Can you just let me know the surface resistance? The surface resistance lies between 0 and infinite. The value of surface resistance or value of any resistance lies between 0 to infinite. When the surface resistance is 0, when the surface resistance is 0, what does that mean? Whenever the surface resistance is 0, the body can be treated as a black body. The black body does not have a surface resistance. So whenever there is a surface resistance 0, the body is definitely considered as black body. How to have the surface resistance to be 0? Can you just let me know, when do we get the surface resistance to be 0? What is the condition for having the surface resistance to be 0? What is the condition for having the surface resistance 0? Can you let me know when the surface resistance will be 0? I want everyone to respond. बताइए. Surface resistance will be 0 in situation when emissivity is equal to 1. When the emissivity is equal to 1, the numerator will become 0. So the surface resistance will become 0. And there is another condition. There is another condition. When A is infinite, when the area is very large, then also the surface or the body can be treated as a black body. There are two conditions. Yes, Sairam, there are two conditions, not one. Either when emissivity is equal to 1, then the surface resistance will become 0, and the second condition is when the area of the surface is too large, it can be treated as a black body. We can assume it as a black body. And whenever the surface resistance is infinite, then the body can be called as a white body. For a white body, the surface resistance is infinite. What is the condition for having the surface resistance infinite? What is the condition for having the surface resistance infinite? When emissivity is equal to 0. There is only one condition. Area cannot be 0. Area can be very large, but area cannot be very, very small. Because without having a surface area, the radiation cannot be possible. Radiation needs a surface area because radiation is a surface phenomena. The only condition is when epsilon is equal to 0, then the surface resistance will become infinite and the body will be called a white body. And whenever the surface resistance is non-zero, then the body can be called a non-black body. For a non-black body, surface resistance will be non-zero and can be calculated by using the formula 1 minus epsilon upon epsilon into. Are you getting it? Are you getting the concept of non-black body? Is this clear to everyone? So two type of thermal radiation thermal resistance I have talked about. One is the space resistance that will always come into picture for the space between two surfaces. Whenever there is a space between two surfaces, there is a space resistance coming into picture. Whenever there are two or more surfaces having the radiation exchange with each other, then there will be a space resistance coming into picture. But the surface resistance will depend upon the situation whether the bodies are black or non-black. The bodies are black body, there is no surface resistance coming into picture. But when the bodies are non-black, then the surface resistance will also be coming into picture in the radiation network or the circuit diagram. Now we are totally ready to develop the expression for the radiation heat exchange between non-black bodies. There are non-black body 1 and body 2. We are talking about radiation heat exchange between the non-black body. The area of non-black body 1 is A1, temperature is T1, emissivity is epsilon 1. Similarly, the area is A2, temperature is T2, emissivity is epsilon 2. And we need to find out Q122 net. Now, can you just let me know, if we draw the circuit diagram, how many thermal resistance will be coming into picture? Can you guys draw the circuit diagram for the heat exchange between two non-black bodies? Between two non-black bodies, how many thermal resistances will be there in coming into picture? What is the number of thermal resistance? Can you draw the circuit diagram for the radiation exchange between 1 and 2, Q1 to 2? Anyone? Give me the number. How many resistances will be there? Surface 1 is also non-black. Body 1 is also non-black. So we can assume the body 1 to be a black body with a cover. Surface 2 is also a non-black. So again we can assume body 2 also a black body with a covering. So the first body will develop a surface resistance. The second body will also develop a surface resistance, and because of the space present between 1 and 2, there is a space resistance also coming into picture. So if we draw the circuit diagram, then there will be two surface and one space resistance. There will be two surface and one space resistance. Can you see it? So this represents the potential of body 1 will be EB1, the inner potential of body 2 is EB2. EB1 and this potential is J1, this potential is J2. All the resistances are in series. So there are three resistances. Then it is R1, surface resistance for body 1, and this is R2, surface resistance for body 2, and the space resistance between 1 and 2 is R1 to 2. There are R1 is 1 minus epsilon 1 upon epsilon A1, R2 is 1 minus epsilon 2 upon epsilon 2 A2, and R1 to 2 is given by 1 upon A1 F1 to 2 or 1 upon A2 F2 to 1. This is how the circuit diagram will be drawn, and the equivalent resistance R equivalent will be R1 plus R1 to 2 plus R2, isn't it? And this can be called as delta EB, where EB1 is equal to sigma into T1 to the power 4 and EB2 is equal to sigma into T2 to the power 4. So Q122 net can be written as delta EB, that is EB1 minus EB2 upon R equivalent, isn't it? Or we can say sigma into T1 to the power 4 minus T2 to the power 4 divided by R1 plus R1 to 2 plus R2. I hope this is clear. This is how we can find out the net radiation, or that can be written as minus Q221. That is also calculated as minus Q22 net, isn't it? If we want to calculate, because for Q221 it will be EB2 minus EB1 upon the equivalent thermal resistance. Is this clear? Is this all fine? Using the same concept of circuit diagram, we can also calculate, we can write Q122 net as EB1 minus EB2 upon R equivalent, or we can write it as this is R1, this is R2, this is R122, or we can write it as EB1 minus J1 upon R1, or we can write J1 minus J2 upon R122, or we can write it as J2 minus EB2 upon R2, or also we can write it as minus Q221 net, isn't it? This is how the concept of circuit diagram can be utilized for this. Any doubt? Anybody is having? That is what I had told you, Madhu. To analyze the non-black body, we can, because the non-black body emit lesser amount of radiation. The non-black body, what is the difference between the black body and non-black body? The black body is the reference body which emits the maximum possible amount of radiation for a particular temperature. And what is the non-black body? The radiation emitted by the non-black body is lesser than the radiation emitted by the black body. So why the radiation emitted by the non-black body is lesser compared to the black body? That is why we can understand the concept by assuming the non-black body to be a black body with a covering. So there is a surface resistance which restricts the non-black body to emit the amount of radiation as per the black body. So that develops the surface resistance. Because of the surface to be non-black, there is a surface resistance to be developed. The formula for the surface resistance is 1 minus epsilon upon epsilon into area. So the non-black body can always be treated as a black body. It was actually emitting EB amount of radiation, sigma into T to the power 4. But because of a cover outside to make it as non-black body, the radiation emitted is lesser because of the surface resistance developed. I hope it is clear, Madhu. That is how the non-black body can be analyzed. Black body with a covering, and the covering will provide a surface resistance. So you can further modify the question, or you can further modify the analysis. If both the bodies are black, then R1, R2 will be equal to 0. Only one resistance will be there. That is R122, space resistance. If one is black, another is non-black, then there will be two thermal resistance coming into the circuit diagram in series. If first body is a black body, then R1 will be 0 and R122 will be there and R2 will be there. If first body is non-black but the second body is a black body, then R2 will become 0. Whenever there is a black body, the surface resistance will be 0, but for a non-black body, the surface resistance will be non-zero. So this is the final expression, the net heat exchange between two surfaces. Q122 net can be written as sigma into T1 to the power 4 minus T2 to the power 4 divided by first is R1 plus R122 plus R2. Or we can multiply and divide by area A1. So we can write it as sigma into A1 T1 to the power 4 minus T2 to the power 4 upon 1 minus epsilon 1 upon epsilon 1 plus 1 upon F122 plus A1 by A2. These are the surface areas, 1 minus epsilon 2 upon 2. This is how the expression can also be written. The unit is watt. This is the final expression for the radiation heat exchange, and this can be compared with the general expression for Q122 net is A1 into Fg into sigma into T1 to the power 4 minus T2 to the power 4. This Fg is known as, this is called as gray shape factor, or we can also call it as equivalent emissivity. It is also called as equivalent emissivity, or we can also call it as interchange factor. So if we compare this general expression with the expression we have developed. If we compare these two, then the expression for the gray shape factor can be written as 1 upon 1 minus epsilon 1 upon epsilon 1 plus 1 upon f122 plus a1 by a2 into 1 minus epsilon 2 upon epsilon 2. Is this clear to everyone? That is called as gray shape factor or equivalent emissivity. If anybody is having any doubt, anything to ask, please do let me know. Otherwise, I will be going to stop here only. That is all from my side. Tomorrow there will be no class, but day after tomorrow we will be analyzing some examples. We will solve some problems. We will discuss some examples where we will modify our expression. This is how the radiation analysis can be analyzed in case of black as well as non-black body. Because there is no class tomorrow, I am giving you a couple of assignments for your practice. This is your assignment number 1. Try to solve this question. Tomorrow you are having enough time because the next class will be day after tomorrow. This is assignment number 2. And the assignment number 3 is same as the question which I have given you for the daily dose. Right? So there are 3 questions which are given. I will share the PDF of this class also. So the next class will be on Wednesday at 7 p.m. and we will continue our discussion for the non-black body. We will solve some numericals. We will see some examples where the radiation exchange can be analyzed. All right. So please revise everything. Please try to solve some more numericals so that you will become comfortable. This is my entire schedule. Those who are here for the first time, please check my entire schedule for this series. We have discussed up to this point. There will be 2 more lectures on Wednesday and Thursday, and on Saturday we will be having the Menti quiz, Menti war for theory of machines and heat transfer. The topic for the heat transfer is only radiation, and the timing will be 11 a.m. Do note the timing for the Menti war. Me and Dheeraj sir will be taking that session. So guys, please revise, please work hard, keep on preparing, and those who are not part of my Telegram group yet, please do join me on that Telegram also. Alright, that is all from my side. See you in the next class. Till then, enjoy, take care, have a good day guys. Good night, stay safe, stay healthy, and keep preparing with BYJU'S Exam Prep. Thanks a lot. Jai Hind.